Thank you, Jim. Good morning. It's a real pleasure for me to be here. My first trip to Korea, my first trip to Seoul, and I'm delighted to be here. The hospitality and generosity is truly overwhelming. I want to take you through three different products in the SAS High Performance Analytics portfolio and tie together some of the concepts you've heard in the previous presentations. Jim Davis talked about big data, about proactive analytics, high-end analytics, the kind of the complicated analytics that SAS is known for. Dr. Goodnight just introduced these blade-based systems that have massive CPU power, massive memory, and how we have used those in, for example, the financial risk area to do valued risk calculations. I like to think of this valued risk calculation as big analytics. It does not require maybe a lot of input data, but it's very complicated and very many operations. Now, when it gets really exciting is when you combine big data and big analytics. The high performance analytics effort is really a customer-driven effort. So everything I'm going to show you now were problems that were brought to us by customers that experienced performance problems because the size of their data was growing, but the analytic techniques they wanted to apply are well established in their respective industries. The first example I want to show is what we call a logistic regression. It is basically a technique used to predict some rare event. In this case, a bank was interested to model and predict the probability of loan defaults. They brought this problem to us because the job they were running was taking hours and hours and hours. And that kept them from asking interesting questions about the quality of the model they were actually working with. So they wanted to reduce the runtime. They did not want to replace the logistic regression with something simpler. The high-end analytic technique needs to stay, but the big data problem needs to be solved. So you heard one definition by Jim Davis of what big data is. There's another definition I like to use. Big data, you know it when you see it. Well, they saw it. When they tried to run these jobs like an analyst in your organization would do, they would, for example, issue this proc logistic run. The problem they wanted to solve was model 500,000 loans, but not at the account level, but at the transactional level, model every interaction with the customers. And when we expanded it out, we ended up with a data set of 1 billion with a B records. So if you were to run this, it would run for about 10 to 20 hours, depending on what machine you would use. What would happen? Let's say I would run this on this laptop. The data, massive amounts, would be brought to this laptop. I would use the CPU on here to try to crunch the numbers iteratively, and that would choke the computations. So now I'm high performance enabling this job, and this is what the analysts in your organization will do. I'm adding the letters HP. And that's all I'm going to do. And I'm going to submit this job. So what's happening now? The square on the right side of the screen displays a computing environment in Cary, North Carolina. 48 blades, one rack. And the green bars are the CPUs that become active now. So I sent the calculations, the instructions to the calculations to the machine, and don't bring the data to the laptop. And the job that took 10 hours just finished in about 23 seconds. Now what you get in those 23 seconds, the output that is being returned to the laptop, is exactly what your analyst will see if they're very patient and in a non-high performance environment wait for 10 hours. So that is the kind of dramatical increase in performance. I'd like to think of it as transformational performance that we can realize with an environment that is distributed, that avoids data movement, that is highly parallelized. But in order to be really, truly transformational, it has to allow you to do something transformational, to do something different. So what is the benefit here? Rather than wait 10 hours every time you hit a button, you can now start to work with those models and ask yourself, Am I using the right variables? Should I change the way I predict? There is lift that I have not realized because I am not taking full advantage of the calculations. Instead, if it takes a very long time to run, you're likely to just assume the results and live with them. The second example I want to run in this environment is one where the data is very, very wide. Jim Davis referred to this issue. What happens if you have hundreds of variables and you're not sure how a particular variable affects the business process you try to describe or model? Well, what if you have thousands of them? So in this particular case, I'm starting with 2,000 variables, and what I need to do is develop a sophisticated model that incorporates the right ones. Well, among those 2,000 are probably 1,000 or 1,500 of not very meaningful variables, but how do I find those out? If any analytic environment I try to approach with this problem will choke on the data. So the first step we're doing here, in parallel, we're reducing the 2,000 variables down to a meaningful set of several hundred, sort of weeding out the obvious unimportant variables. And then in the second step, we feed the remaining 200 variables into a very, very complicated, very high-end variable selection technique called a lasso method. These methods typically do not get applied to such large amounts of data, but the high-performance analytics environment allows us to stay with these complicated statistical methods and apply them to large data as if it was small data. And so the job just finished, and what we thought previously was not possible finished before I even could describe the problem to you. So this is one example of how statisticians or how analysts interact with the SAS software in your organization through this programming language. Let me show you some other ways and some other solutions that we have high performance enabled in this way. What you're seeing here is the interface to our enterprise miner application. The business problem I'm trying to solve now is more complicated than the previous one because not only do I have very complicated statistical methods I want to apply, I am also not sure about which method I should use, and I have very, very complicated data. In this application, we model 10 years of all domestic airline flights in the United States. So there are about 110 million of those. So the information was gathered by surveying the various airline carriers. So we want to have information was required, for example, about the length, the time to taxi, the time an aircraft would be at the gate and so forth. And those carriers don't report this information in exactly the same way. So you get sort of a mix of information, a mix of variables that has to be combined into a meaningful data set for analysis. So that is what your data scientists and analysts are struggling with every day. How to combine various data sources, how to turn this into meaningful data that you then can actually apply high-end analytics to. So the little rectangles in this process flow actually represent the various steps in this process from gathering the data, separating the data into a part for model training, a part for model validation, transforming the data, imputing missing values, exploring the data all the way to the analytics, and we take it a step further, all the way to some form of a scoring equation that you can then feed into an operational system. So I want to point out that these letters HP are in front of really every single one of those rectangles. So we did not just high performance enable the calculations themselves, but also the manipulation of the data, the transformation of the data, how you interact with the data. Finally, I mentioned at the beginning of this example that I am not quite sure what is the right analytic technique for this problem. However, I know there are several candidate methods that in the industry are typically applied. All these candidate methods have in common that they're very, very computationally intensive. They're high-end analytic methods. And each one of those would require hours and hours of runtime. For example, the rectangle at the top represents a neural network. When we timed this run, it would take 19 hours just to complete this rectangle in a non-high performance environment. Well, this job will finish while we're talking about it. And you see that not only am I executing a neural net, which executes in parallel, as you can see, on the appliance, two more techniques are running at the same time. Here's one technique, a second technique, and a third technique. And while they're executing, I can then ask the software the question, which of those three techniques is actually superior? Which provides the best explanation of why these airline flights are late? And let the software guide it all the way to finding the best scoring equation. And so you have, again, the ability to improve on the way you do the business because you can handle large amounts of data without using simple, substandard statistical techniques. So while this is running, let me briefly introduce the last application I want to show, a really fascinating one, and Jim Davis mentioned it earlier. Optimization of marketing campaigns. What you're seeing now is the interface to our marketing optimization solution at SAS. And if you are running the non-high performance version, this is exactly the interface you'll be seeing. So like in the previous two applications, what we have done is enable the calculations in the back end to run in a high performance environment without changing how you interact with the software. So basically we took marketing optimization and turned it into high performance marketing optimization. The problem I need to solve is the following. I have a fixed budget for a campaign with which I want to reach 20 million customers of a credit card company. So Jim Davis gave me $11 million for this campaign, which means I can spend about 50 cents on each customer. So how should I do this? First, I need to select which channels do I make my credit card offers through. There are a number of them, and in this particular situation, we have 8. There are airline discount offers. There are airline discount offers, cash advance offers, offers through rewards program, and so forth. In addition to these policies, there are constraints, limits placed on this overall campaign. 1, I cannot exceed my budget. 2, in each of those channels, I'm going to limit the number of offers I can make. I can't just make an arbitrary number. So let's say 2.5 million offers is the absolute maximum for each one of those channels. Now what makes this a really complicated problem is that in addition to having these limits, I want to personalize the campaign. I want to take into account what I know about my 20 million customers. So the jobs I just ran previously could have, for example, predicted the probability that a customer might respond to a particular offer through a particular channel. Well, this is input for this marketing campaign. So in addition to the constraints, I'm going to limit the number of offers that any customer can get to 2. And if a customer gets more than one offer, it has to come from separate channels. So now if you take all of this together, all this mix of constraints and limits and policies, you're dealing with about 1 billion, again, decision points as to who should get what offer. It's a very complicated optimization problem. So it's a big data problem and a big analytics problem. And I've submitted a job, and it's running out here on the appliance, and you can see the CPU activity. We're now trying to find out the optimal solution for this particular campaign and the set of constraints and policies I've put in place. This would run for several hours, and it will finish in about 90 seconds now. So what does that mean to your business in organizing marketing campaigns? The software, whether it's high performance or not high performance, will give me an optimized solution. So I know the numerical solution I get will be the best I could hope for in this set of circumstances. But what I don't know is if there are better solutions out there. So imagine you bring all your marketing directors together in a conference room and you start a brainstorming session. Said, okay, here's what we currently have. These are the constraints and contact policies. This is the budget. And what is the answer? Oh, it's just finished. And under this particular setting, the expected profit from this campaign would be $19.1 million. Well, could I have raised that profit? So let's first study what this analysis is trying to tell us. What you see on the screen here, and it's probably difficult to read from the back, so I will point out the salient points, are the results for the optimal solution we have found with respect to your constraints, your limits. The first one is the budget, and the other 8 rows are the various channels, each of which we allow 2.5 million offers. And you notice 3 of them are highlighted. Well, those are the limits that we have met. So the first one was $11 million budget. The actual value that was realized was $11 million. Not a cent left unspent. But thank goodness I didn't go over budget either. The other 2 bars represent 2 channels, the merchant offers and the rewards offers. In those 2 channels, we will have made all 2.5 million offers that we allocated. Now, interestingly, the numbers in the white rows are much smaller. For example, the last one I read it off, the travel offers, only 67,000. We make 67,000 offers, but we allocated 2.5 million. What would happen if I would actually raise that? Well, under this scenario, I cannot because this solution limits me. But possibly you could reallocate and allow for more offers in another channel to lift the travel channel. Is that a better solution? Possibly. But how can you find out if you don't have the ability to ask these what-if scenarios and rerun? So I made one simple extra scenario that I want to run. In this, I simply asked myself, what would happen if I go into Jim Davis' office and ask for an additional $1 million for my marketing optimization instead of a marketing campaign? 11 million, can you give me 12 million? What is he going to ask me? What do we get for it? What's the return on the investment? Well, if your marketing campaign strategy is based on guesswork, you might say, well, we make so much money, and then you do the campaign and you fall short. It's not good. Well, now I can actually run the scenario, and I get the optimized solution for that other case, for the $12 million budget. So if it comes out in my favor and I actually have a return on the investment, I will go to Jim's office and say, here's a good idea. Let's spend more money on this campaign. If it comes out against my favor, I will never tell him that I had that thought about raising the budget. So this is running now, and it will finish just like the other one in about 90 seconds, and we can compare the numbers. So what you've just seen are 3 applications, 3 products, all based on the idea that we want to bring high-performance enablement to the software, to you, the user, without changing the way in which you interact with the software, so that transition is easy. The investment you've already made in training employees is not lost. Sometimes people think you need to reinvent the way you do things in the high-performance analytics world. For example, you need to have a new programming language or something. That is not true. You simply need to enable the things that work well for you. So this is just finished, and the number at the top is $19.9 million. So we raised the profit from the campaign by $800,000 by asking for another $1 million. It's a good idea. So Jim is already eagerly awaiting me at his table so I can make my request. At this point, I would like to turn the presentation over to our Executive Vice President for EMEA and Asia Pacific, Michael Hagstrom, who will talk about the business value.
Today, I wanted to share a little bit around the business implications of this and what we've just seen. And I've labeled that analytics to fuel innovation and inclusive growth, because analytics has reached a stage when it can leverage data as your new asset class, as one of your largest asset class, and that's what I want to take you through a little bit today. It's hard to find a news article today from a bank or any other industry when the chief executive officer doesn't talk about this topic. And very often, as you're well aware, the teams are called together and asked, what are we doing about this new asset class? And that's what I want to touch on a little bit here today. But to do that, I want to give you a backdrop of what we're actually dealing with. There is a new environment out there, and the complexity is the one that I think strikes the most. Not just that the economies are interlinked. We have a slowdown in Europe, and clearly that's impacting the world at the moment. But also the supply chains are interlinked. We have the devastating earthquakes in Japan, and then the floods in Thailand last year that led to disruptions when Silicon Valley was running out of its silicon. So we're dealing in a world of complexity. We're dealing in a world of a lot of challenges, socioeconomic challenges, chronic fiscal labor imbalances. They are common for every government around the world, and they impact how we run our businesses and governments. And as in the past, we have reached a stage where we have to do something fundamentally different. And that's what I want to talk about, because I think, as in the past, technology has come to save us into a new era of growth, so will technology come to do that for us again. It's a volatile, it's an uncertain, and a complex market. We have big challenges, we have less time, we live in the new normal. So what is new on the asset side? Well, we have the big data that we hear a lot about, and we've heard a lot of presentations around today. And there are three major trends. On the big data, I think the largest trend really is that it coincides with the technology that you've seen. What you saw was big data running on commodity hardware. So imagine this. Everything we've learned in IT, which is around how can we work around CPU limitations, memory limitations. And we have learned that by splitting up tables, creating indexes, to subject-oriented data storage, third normal form storages, cubes, you name it. Imagine if you don't have to do that anymore. And what you just saw was an example of that. Oliver showed you over 1 billion records. 1 billion. Take the population of Korea, Japan, every single citizen. Add everyone in the United States, everyone in Europe. Make one row for each citizen and a few variables to describe each citizen. 30, 300. And you can get instant response times when analyzing this data. Or take everyone in China, 1.3 billion, and analyze it. On commodity hardware, that's what we're seeing. Now, it's not going to stop at the big data you saw in this example, because most organizations still look at big data focusing on internal data. And internal data is very important, but sometimes there is information about your most loyal customer that is not in your internal data. I'm thinking of taste. For instance, music taste, or the type of data that's in the social media. The experience, what you share. It might not be linked to a particular individual, but it can be linked to a segment. The hyperconnectivity is opening this stream of unstructured data that can create a picture of your competitor's most loyal customer, the one that perhaps is the least loyal to you, the one that could represent the highest uplift for you, and you could learn something about that client that your competitor don't. And if you don't do it, your competitor might do it on your most loyal customers. And the example that we've seen, and also in front of you, I believe you have some customer stories around high-performance analytics, one of which is Catalina Marketing, which you're going to find there on page 12. So Catalina Marketing, they used to run a very large number of campaigns. See if I have the number here. In the past, they used to launch 20,000 new products in a year. But they did that through 40, 50 models. They didn't have the ability that Oliver just showed, which is that you can rerun the models until you have the one you want, until high performance analytics was introduced. Today, they do 600 models, the same people, 600 models, and they have a very clear understanding of how to go to market. The other example is around real time, the ability to react real time. We see it more and more on the websites, and this morning they were talking about, Sheikha talked about Amazon. But there are retailers out there now in the Amazon family that actually uses your real-time information, not just your past behavior. You might think you're just having a social chat with a call center agent on the other side, but you're actually talking to an analytical server. Or we might do campaigns to prepaid telco, where the only thing we know is how they respond to the campaign. Again, a new data class, the real-time data class. The other aspects of that, of course, is the time, the speed. You heard about UOB. The UOB example, which is also documented in here, that's on story number 22, on page 22. In the beginning, they calculated the value at risk, all right, but they didn't finish the calculation for the previous trading day until the new trading day started. Now, of course, they know before they start the trading day where they ended the last day. It also allows them to move in and out of markets faster than the competitors. The value of moving in and out of markets before they do is a clear competitive advantage for them. And of course, when we come to the usage, a lot of the departments in your organizations are struggling to get the information they need. So they create copies of the data, instances of the data. Now, if we can deliver what they need with one single version, we have a unique environment, one that's competitively using the big data. So I think as we look at the history, the bottom bar here pretty much shows how we evolved in the area of analytics, but that I think is true in pretty much any other part as well. For those of you that have teenagers will probably recognize it. Today you might not think that they're going to be smarter than you are, but history has shown they will. So just relax on that front. They will get smarter, each generation do. But the challenge, which is the top bar, the need for speed, larger volumes of data, more complexity, is growing exponentially, and we're not going to fill that gap by simply moving faster. We have to work smarter. And that's where high performance analytics come in, because it's high performance analytics that converges these pillars on their own. They are simply a cost item. I know many of you have IT expenditures that if we look at an area like, for instance, disk or storage, keeps growing and growing, and you might not see the return from that because it's treated standalone. But together, these can resolve the challenges that we need. It's a new environment for analytics, but it's this new environment that will allow you to capitalize on these core assets, how we can bring these asset classes to bear to drive innovation and growth. The other area I want to talk on, not just the platform. So we have the technology, you've seen it, it's working in action, but the next area, of course, is users, skills. Where do you find analytical talent? It's a global market shortage for analytical talent. Everyone searches for analytical talent. Now, Sam here has been exceptionally successful, and he has some of the best analytical talents in Korea to your disposal, but we're going to need more of them. And the solution there that you're going to see in the next session is how we democratize the usage. Personally, I believe it's the only democratization you're going to see that doesn't include raised taxes. But anyway, here it is for free. You're going to see it in one session, which is how users can, without understanding how neural networks work, can actually leverage those. So let me give you some concrete examples, put some numbers on the table. Last year, in about October, Francis Maude's cabinet in the UK, that is, went out and said, and talked about the value of open public data. They were talking about the competitiveness of the of UK, and they were talking about the competitiveness, not just within Europe, but globally. And the big data they had recognized was an asset. So on the back of that, we did a survey. We asked the Center of Economics and Business Research to do a survey, go out to CEOs and leaders, and they came back with these numbers. Efficiency, which is what you just saw Oliver show. Same process as before, but speed, which allows you to have more fact-based decisions, was valued to 124 billion pounds sterling. The other area, which is innovation. Innovation is when we can do a business process a bit different, because we now have capabilities we didn't have before. We can do things in a different way. That added 58,000 jobs. I'm going to give you an example of that, and 150 billion. The business creation, which is about waking up the sleeping giant at services, combine the service, the experience to the client, I think is grossly undervalued at 42 billion. But it's because it's abstract. It's not just invented. But the company that goes there first will have the highest benefit. Still, over 300 billion pounds sterling in 5 years. That's a major lift for any economy from this. So let me have a look at one other concrete customer, because I've talked about 2 customers so far. I've talked about the speed with UOB. I've talked about complexity with Catalina Marketing. And now I want to talk a little bit about volume of data. And a very good place to go to talking about volume of data is, of course, the financial sector. So let's have a look at RBS. RBS was a bailout from the times when the government went in and did a bailout. Was, you know, US separated banks, the UK went opposite direction. They took the 2 banks that they had to bail out and did a super merger. And the challenge for them then, of course, was how are we going to consolidate our global risk exposure from all these already merged structures being brought together to a super merged structure. It took them more than a month to manually do this. So that's why they called us in. We started to work with them on that, and we brought together all the risk data, not physically in the sense of a warehouse, but by identifying what data was where and used that in bringing the risk exposure and calculating risk exposure together. As we did that, we realized, well, we can do the same for marketing data and financial data. And when we've done that, we said, why not calculate the risk-weighted performance by client? So we started to calculate the risk-weighted performance by client. And we got those jobs down to 55 seconds. Well, now I'm going to share the relevance of these 2. Because first of all, the volume, the fact that we could handle large volumes of data, allowed us, as Oliver pointed out, to discontinue using samples. We could train the models on all the data. And the fact that we could train the models on 10 million customers raised the lift, so they saved hundreds of millions of British pounds within the first month, and they went public on that. So the whole project was paid hardly before we got started. Now, that created a lot of courage amongst the board members to allow us to do the changes that we then discussed, and was also recommended at that time by McKinsey, which was their choice. And that was to, rather than to have the client-facing executives to send the request to the risk department for an approval for a credit, if it only took 55 seconds, we could calculate the risk-weighted performance for each client. And if we can do it in 55 seconds, we can let the customer-facing staff answer there and then, creating a situation where the client isn't going to a competitor to get comparable offers, but actually agrees there and then, and the client executives could say, yes, you're approved. And by the way, if you also look at this product, I'm going to give you a very good rate. Now, that is competitive advantage, where they can serve customers faster. By changing the process from the 300 risk people to the 3,000 customer-facing people. But what what if we can really democratize the user interface? What if we could allow the 3 million small and medium enterprises that today has no ability to do liquidity risk management, to do what if and scenario plans in a service-based cloud? What if they can go in there and see what happens to my cash flow if I take this credit now, if I make this investment, what's going to happen down the line? Well, it's going to help them to stay out of defaults. It's going to help them understand why the bank reacts like they do. And you can imagine the government really wants to pass credit down to the small and medium enterprises so they can drive inclusive growth, create more jobs. And the bank, of course, wants less defaults. So now you have a new service provided, potentially by the bank, and you've also democratized the usage and given the small and medium enterprises an ability to work differently and drive growth for the economy. Now, these are the kind of workshops we work with our clients on. We usually spend a day together in a workshop to see what's possible. Now we have brought the best skills together, those that have experience from doing those workshops. And what I want to do is to make them available to you. I mean, to those of you that answers first, that is, because once I promise them to the first responders, then I will not, we will have to wait until we can do the others. But those workshops is about how we can take a step into the new normal and leverage big data as a new asset class. And that's my offer to you today. And Sam and his team are happy to follow up with you. So if big data is the new oil, as we read in the newspapers, then high-performance analytics is what will energize the new economy. And that is what I wanted to share with you today. Thank you very much. Now, ladies and gentlemen, Dr. Goodnight is going to talk about the new user interfaces.
Well, you know, our vast computing laboratory did a wonderful job on the high performance. And I asked them to, once they developed all the rules and procedures for how to do this high performance analytics, I said, well, we also have one other thing that we'd like you to do. And that's, we would like to have an in-memory server that does some more of the simple things like BI, charts and plots, and be able to do this on large amounts of data. So I want to give you a quick demo of that. So let me sign in here. So I'm logging on to our Visual Analytics Explorer, and this is a brand new interface for us. And what I'm going to choose that I want to explore data. Now the server has got a number of data tables already preloaded into memory, and to start this out, I need to select one of the data tables. And the one I want to use is called a Megacorp, and it has over 1 billion records in it. So now it's establishing for each variable how many different values there are. So if it's a finite number, then they're considered to be categorical variables, and otherwise they're considered to be continuous. Now, we are right now in an automatic charting and plotting mode, which means all I've got to do, and excuse me one second, I'm going to make these fonts a little bit bigger. My old eyes has a hard time seeing them. So. What I would like to do is I want to do some revenue by year. So let's drop the date by year out here. So now we want to look at revenues. Well, I want to look at expenses too while I see it there. Here's profit. Let's drag that out as well. And here's revenue. So I'm going to take revenue and drop it out. So what you're seeing is it's summing up revenue for each year. It's summing up profit for each year and expenses for each year, and then it's joining those together. Now, once again, let me remind you that what you're seeing is nothing that's been pre-computed. Everything is being computed as we go through this. The data table has 1,158,000,000 records. We're dealing with over 1 billion records, and there's 46 variables. Now suppose I would like to get this done a little bit finer, so I want to replace date by year with date by month. So this will give us a much finer grain. It'll give it revenue totals at the months. And what you see on the bottom down here is the actual total distribution of all the months over the 32 years. And up top, you just see what's under the window. So if I move this visual window along, we can actually come over here, and this is some of our peak months occurred right here. And all I have to do is hover over that, and that was May of 2000. So after May of 2000, we see the revenue more or less fell for a while, went back up. But this allows you to explore, again, over 1 billion records. And you see how, and the reason it's so slow is this is being done on the other side of the world and having to be sent back here. So I'm impressed though with the internet speed that we're getting between here and North Carolina. It's very, very, very good. You know, one of the things that we want to be able to do is do drill downs on hierarchies without building cubes. So I'm going to do a new hierarchy. I'll just call it ABC. And what I want to do is to have the region of where each facility is located, and the state where each is located, and then the city where each is located. So we have now defined a hierarchy, and now let's operate on that hierarchy, and I'll show you how to do drill downs. Remember, this hierarchy didn't exist. I just defined what it was. So now let's drag that hierarchy out here, and let's take a look at, let's look at expenses in each one of these areas. Let's look at revenues, and let's look at profit. So now, on the fly, we have over 1 billion records, have built the hierarchy that has the region. And if I want to drill down on a region to see what the states are, here we see the states in that region. And if I want to drill down on a particular state like California, I can see the values at each of the cities. But again, this is all being done in real time as I stand here. Now let's go back and drill down on the south. We see the Texas, Arkansas, Alabama, Louisiana. Drill down on Texas, and we see Houston, Dallas, and Corpus Christi, and you can see the values there. But the concept of building cubes for OLAP should be history. It's an awfully expensive thing to do. It takes huge amounts of disk space. Jobs run all night, use up all sort of resources. There's no reason to ever do that again. We can do it simply on the fly. One other interesting thing that you don't see very, very often, I'm going to do a box plot. A box plot is a sort of a statistical thing. So This is the kind of thing you could ask an SQL database to do, and it wouldn't know what you're talking about. So let's go back and choose a grouping. Let's go to the state, the facilities in each state, and let's pick revenue and drop that out there. So this is going to do a box and whisker plot, and you see how fast that was done. This is an incredible amount of computing that was just done. New York, for example, we had to go through 1 billion records, 1.1 billion records, and find all the records that belonged to New York. Then we had to rank those from low up to high, and then move up 25% of the way to get the 25th percentile, the 50th percentile, and move on up to get the 75th percentile. And then we had to box the whiskers, and we had to find the value that was within the highest and lowest value with just inside those whiskers. So here we have that result. And then we had to do the same thing for New Jersey and California, for all of these things. And you see how fast that was, over 1 billion records. Another thing I'd like to show you is what happens, and we're back into auto, it always goes back into auto plotting mode. Let's go back and choose, let's choose, excuse me, my mouse is going crazy here. Let's click on unit age. And the last one down here. Let me try again. I'm having some issues here. There, finally got them. Okay, let's drop these 10 variables out here. And how are you going to plot 10 variables? Well, it figures, probably what you want to do with that is to compute a correlation matrix. 1.1 billion records, we've just computed a 10 by 10 correlation matrix. The darker the color, the higher the correlation. So here with the unit reliability, we have a 0.93. Let's drill down on that. We can actually see the data and the red regression line, the linear regression line that corresponds to the 0.93. So we can see it's fairly accurate in the early years, but as the age gets a little bit longer, it's not quite as good of a fit. Now let's click on another one. So we can keep drilling down and drilling down. We can look at every one of these correlations, and we see the results there. That's not quite as good a fit. So that's the basic concept of visual analytics. This is one of the first things that business users want to do when they get a large, they work really hard to pull data in from all across the company, from all the different silos, and then they want to explore it a while, get a feeling for it, what variables are related to each other. So that's the Explorer. Now there's another part of this, which is our visual designer that allows you to design reports for other people to look at. And Deepak, will you come up and take us on a tour through the designer?
Thank you. Good morning. I'm going to walk you through the Visual Analytics Designer, which is, as Dr. Goodnight pointed out, it's a reporting tool, but it's also a reporting tool for generating reports on massive amounts of big data. It's called big data. The Visual Analytics Designer is built around 3 central themes, and those 3 central themes are essentially ease with which you can build these reports. The second is collaboration. How can you use reports that have been generated by other people, explorations, analytics that have been generated by by your colleagues, by your peers, and import that data into import that report into your scenario. And third is dissemination, is spreading that information across onto browsers, onto mobile devices, and how people can start consuming and playing, interacting with that information. So those are the three central themes of the Visual Analytics Designer. We'll walk you through those three different themes. So here I'm going to click on New Report, and this starts up the Visual Analytics Designer. As you can see, it sort of just logs on in a very quick time. The first thing I'm going to do, of course, is I'm going to choose a data source. So the first data source I'm going to choose, in this case, is the same one that you saw Dr. Goodnight opening up a little while back, which is the Megacorp data, which is around 1.15 billion records of information. So as it loads this data into the Visual Analytics Designer, I'm going to start off with a very simple chart, a very, very simple chart, which is I want to look at my product lines, and I want to look at the percentage profit contribution of all of those product lines. So I'm going to pick a pie chart, just drop it in here. The pie chart comes up, and here I'll pick up product lines. As you can see, it shows that there are 4 different product lines I have. I drag and drop it. It asks me it's a categorical variable. When I click on it, it loads up the product lines. Right now it's giving me a frequency. What I really want is the profit. And I drag and drop profit in here and click on show values as percentage of total. And as you can see, within 4 clicks, I've actually got a chart on a large amount of data, which gives me my percentage profit contribution. Right? So I can just rename this as, there you go, percentage profit contribution. That's my first chart. So it's very easy to start building these reports on these large amounts of data. The second one is you saw Dr. Goodnight creating these analytics, these box plot charts, these correlation matrix. Is it possible for us now to be able to incorporate that inside your reporting scenario, or even the drill downs? So let's try one of those drill downs in here. So I'm going to import another report, and the same drill down that you saw a little while back. So it shows me that these are all the objects that are available. I click on this, I take a look at it and says, yep, that is the one I want. And I click on insert visualization, and now I have this same drill down that allows me to look at drill downs along these different, so I look at game for toys, I drill down a little further, it goes down into boards, and I can keep on drilling down. Again, this is going through very, very large data, but its response time is extremely fast by the time that you can actually drill down this information. So this is the way we can actually take somebody else's analytics, someone else's exploration, someone else's cubes, or the kind of drill downs that you want, and incorporate that into your reporting scenario. The third one, of course, shows you the interactivity between different measures within your organization. So you may want to look at one chart, but you may want to look at its interactions with the other ones. So I'm going to build first my favorite one, which is a time series plot. I drag and drop a time series plot in here, and I'm going to put it by, say, date by year. So this is 32 years data that I'm adding onto the time axis. And I'm going to look at it by the usual measures that we saw earlier on. Expenses is one of them. Revenue is another one of them. And it's a new measure. And the third, of course, is profit. And there you go. This is your typical cash flow. This is giving me my cash flow for the last 32 years, right? So I'm going to call this cash flow analysis. But as a business user, your business analyst might have questions like, what was the snapshot in time? At this moment of time, when we really peaked in our business in terms of revenue, in terms of profit, how did all my states do? How did all my products do? So to take a look at that, it's as easy, for instance, as very quickly dragging a cross-tab report, and I want to do a state analysis, which is I've got all of these facilities in all of these different states. So I drag and drop the facility in there, and then same thing. Let's look at expenses. Let's look at revenue before we get profit in there, and then finally profit. And there you go. It's sort of summarized all of this data by your different states. If you want to look at, I wonder which was my most profitable state in all of these years, I can just click on descending by value, and it immediately sort of sorts it and says, well, the most profitable state has been California. Again, this is going through this massive amounts of data. Let me just expand this a bit so you can see the numbers. And last, but certainly not the least, we're going to put in a bullet graph in there. And here, I'm just going to make this a bit vertical. And in this case, I'm going to look again at my product line, which is not only at this point, what did my products look like? So that's product line, and I'm going to go for actual. And of course, like any KPI, there is an actual and a target. And it asks me for the target. Now this is a really clever functionality from SAS, where we can actually go in and pre-populate the intervals in there. And once I pre-populate the intervals, there you go. My charts are ready. And I get my cash flow advance, my most profitable state, and of course my target prices versus actual prices for the products. But where it becomes really interesting is how do I sort of build some interactivity between these three. And the way we'll do that is I'll just drag, click it here, go on to full screen, and now I can now look at snapshots of my business. So if I click on, say for instance, date by year 2003, I would love to know, if I click on this, what were my profits, which was the most profitable state, and here, what was my profit and my product line actual price and target price. So at any moment of time for the past 32 years, you can actually take snapshots of your business right here, and just processes that data and gets the number back to you. So as you can see, we saw three things that the Vision Analytics Designer is targeted towards. One is ease of use, ease with which you can build these charts. Two, to share information, to share collaborations, to share analytics that you might do in different user interfaces. And three is what we're going to look at now, is essentially disseminating this information or passing this information across. So let me go ahead and save this. And I'm going to save this as, here we go. Let's make it HPA Soul. Now once I've saved this, it now becomes available instantly onto the mobile devices. Right? So any report that you've actually built now becomes available on your mobile devices. As you can see out here, I'm going to click on the SAS BI application. And when I click on the SAS BI application, it sort of gives me a list of all my reports that are available right now. Let me go into my library, and I'm going to pick that exact report that we saw a little while back, which was in public folder. And there you can see HPA Soul. It's now available. I click on. So you can see the author is Dr. Jim Goodnight, and I subscribe to it. I say I'm interested in seeing this report. So what happens is the report then goes into a download mode, and you can actually download, and now it's available for viewing. So these were the same reports that we built on that massive data, on that billion record set data, which is now available for you to view on your mobile device. This one, of course, being the profit contribution by product line. The other one, of course, is the drill down. But the very clever feature in this is we have drill down capabilities now right on the mobile device. So in this case, let me see, I can go down to game, and so it drills down on game. I can go down to toy, and it drills down on toy too. And it can go down to multiple levels as you have defined. And this is all available now in the tip of your hands. So it's addressing those big data concerns, on reporting big data concerns right in the tip of your hands. And last is the report that we saw, which is the Interactivity Report. So as you can see out here, again, it's the same, my cash flow numbers, right? And I can actually then pinpoint any point here. And it will reflect automatically the states, the revenue by all of those different states. As you can see, California was very profitable in 2008, whereas in 2003, it was Arizona, right? So you had that drill down capability right on your mobile device. Now, since we are the Intercon, I thought there are multiple reports that are available, sample reports that you can look at. But since we are right below the 7 Luck Casino, I thought I'll show you a nice example of, for instance, how casino data actually works. So this is kind of an interesting report. It's essentially for a casino, looking at revenue by customer. But the interesting one is the key customer look. So because we can now number crunch this massive amounts of data, we can do unique analysis for all the different unique customers that you might have within your organization. So let's look at this customer list. On this axis is the name of the customer. On this axis is the number of counts, the number of times, the number of trips that those people have made into the casino. So if I look at the customers, for instance, let's look at Olivia. And as you can see, Olivia spends a lot of time in the casino, on food, on retail, on beverage, but not enough on hotels. So perhaps we can ask or give Olivia an offer where we can look at offering a free night stay at the hotel. So what it actually does is it allows you to get very detailed information about your customers on the tips of your mobile device. Likewise, you can actually then drill down on each of these. And for instance, Alexander Anderson spends a lot of time in beverage. And if you click on beverage, it actually gives you a highlight. For instance, what is the revenue that the beverage got, how much number of times that the person visited the restaurant to consume the beverage. That's the level of detail we can go down to because of this advancement that we have in processing this massive amounts of data, right? That was the last of my demo. Thank you very much for your time. I'd now like to call Shekhar to walk us through the closing comments of the session. Thank you. Thanks, Shekhar. Thanks.